So here we are looking at systems of linear equations. The first video is going to be just an overview, an intro of what it's all about. The second video I'll make is the solving techniques that we're going to learn. And the third video is different types of solutions we might expect, and then the applications that we would use this system of solving on. So let's look to see. Oh, good catch there. So, what is a system of linear equations? It is when you have two or more equations, and in this case linear, with two or more variables. So this first setup is often what it looks like. We'll have a linear equation, a second one, and I just sketched in what we know the graph of that would be. And then we have this kind of set brace here. It's not acting as a set brace, it's really acting, telling us that it is a system. These two are to be considered together. So the question is, for a system of linear equations, do they have a common solution? We know that these plot as straight lines. There are many, infinitely many solutions along that line. That's what creates the line, all of those solutions. But the question when we have a system is there a common one? Is there one x comma y, one ordered pair that works for both, that satisfies both equations? So I pulled out of my hat one ordered pair. And I'm asking, is this going to be a solution? Because it would mean that it works for both of them. So if someone says, is this a solution for a system? All you have to do is plug in these values into the equations that you've been given. So is 3 the y? And I'm just following these two equations, look. And I'm just using the colours so you can see which equation is which. And in black I'm putting in the numbers that I was given in my ordered pair, in my possible solution. Is 3, the y, equal to negative 2 times the 1, add with the 5? Well, negative 2 times 1 is negative 2, plus 5 is 3, so yeah, it works for this one. So check, works for that one. Is 3, the second equation, does the value of y equal 2 times 1 plus 1? 2 times 1 is 2 plus 1 is 3, yeah. So it works. So this is a solution for this system. It is the only solution for this system. There will be no other ordered pair that will work for both of those. So that's really what a system is. Either two equations with two variables, maybe three equations with three variables. And we're going to look at, see how we can solve. Is there a common solution? On the second video, we're going to be looking at the solving techniques. To solve by graphing, we're not going to explore, except for me show you what it is on this video. Because the problems with solving by graphing is it can take up too much time and is not always accurate. This is what a system looks like, however, and that's a very useful thing to be able to keep in mind. If I've got two linear equations, I've got two lines. With any luck, they'll cross, they will have an intersection point, and that is the solution. Recall on the previous slide, we had an ordered pair that worked for both equations. This would be where it is the intersection. So a point on a graph, if you're given a graph, you can find the solution because it's at this point. But I want you to pretend that you had to make a graph from scratch. You really didn't know where the solution was going to be. You didn't know how far it was going to have to go out. And what happens if they intersected not at a very handy point for reading off numbers? That's the problem with graphing. But as a visual to explain what it is, very useful. Algebra, that's how we're going to learn how to solve. We're going to use algebra. We're going to use a technique called substitution. We're going to use a technique called elimination. Why? Because they're accurate and they don't take too much time. So the benefits of this are exactly what the problems with this were. So that's why we're going to pick algebra. And then the third video will be different types of solutions that we might come across. This one is, there's going to be one solution, there is one intersection point. Think about what this is going to mean. If two lines were parallel, how many solutions are we going to have? And think about this one. The two lines happen to be the same line. What are the solutions going to be? So we'll explore that, and there's some classification words we're going to have to learn. And lastly, we're going to put it all together when we do applications. So, you know, Joe has $10 a week and saves, Joe has $10, saves $2 a week. Jane has $20, saves $1 a week. Will there ever be a time they have the same amount? So as soon as we see these keywords of same amount, same time, we think, oh, two equations set equal to each other. Maybe they will be the same at some point. And another really nice one is kind of number puzzle one. So you're given the sum of two numbers is 7, the difference of two numbers is 17. What are the two numbers? In both of these cases, you'll notice we've got like two clues. In here, a sum clue and a difference clue. In this one, a clue for Joe and a clue for Jane. Two clues. If we've got two clues, we should be able to write two equations. So we should have two variables. In this one, the two variables would be the two numbers. In this one, we've got the two variables will be how much have they got and how long did it take them to get there. So that's what we'll be exploring. So on video 2, we will start looking at our solving techniques.